Hello guys, in this tutorial I'm going to solve the question number 8, paper 31 June 2022. The equation of the curve x cubed plus y cubed plus 2xy plus 8 is equal to 0. Express dy by dx in terms of x and y. This is implicit function. Let's start now to revise how to find the derivative of implicit function and if it is not implicit function. We differentiate respect to x. So if your expression, let's say in terms of x, derivative of x will be 1. So if it is 2x, will be 2. If it is, let's say x squared will be 2x. But if it is y, will be y dash, or dy by dx. If it is 2y, will be 2 and y dash. If it is y squared, will be 2y, then y dash. If it is x times y, it's u and v. Differentiation of first, 1 multiplied by second, plus differentiation of second, y dash multiplied by first. If let's say e power of x, it's e power of x, but if it is e power of y, will be e power of y, then y dash. Let's start now to find the derivative. X cubed is 3x squared. Y cubed 3y squared, but don't forget to write y dash, plus 2xy. Let's say this is u and this is v. Differentiation of first is 2 multiplied by second, plus differentiation of second, y dash multiplied by first, 2x. Derivative of 8, 0. Derivative of 0, 0. So the answer is 0. Now, how to get dy by dx in its simplest form? All terms included y dash, keep it left hand side, and take y dash outside common. So y dash outside common will be 3y squared plus 2x. And move to the other side, negative 3x squared. Move to the other side, minus 2y. By dividing, y dash is equal to, or instead of writing y dash, he asked to write dy by dx is equal minus 3x squared minus 2y, all divided by 3y squared plus 2x. This is the final answer, finding dy by dx in its simplest form. Part B, the tangent to the curve at the point where is x equals 0 and the tangent at the point where is y equals 0 intersect at an acute angle alpha. Find the exact value of tan alpha. First, how to get the angle between two lines in general. If we have, let's say, two lines, line 1 and line 2. To get the angle alpha in between, we have to identify the gradient of first and the gradient of the second. Whereas the M1 is more than M2. To find the angle in between, tan alpha, acute angle is, start with the big one. Tan alpha is M1 minus M2 divided by 1 plus M1 times M2. M1 times M2 to get the angle between any lines, any two lines in between. Tan alpha is equal M1 minus M2 over 1 plus M1 M2. So you have to identify the gradient at this point and the gradient at this point, then apply this equation. We already have dy by dx. So you can use it to get the gradient at the given points. I will start from this point, which we already have the gradient of each, but in terms of x and y. X equals 0, let's first find the values of each. X, when x equals 0, y equals what? You have to substitute in the original equation. When x is equal to 0, y equals 2. When x is equal to 0, remove x and write 0. When x equals 0, y cubed equals 8. So y cubed equals minus 8. By taking a cubic root will be negative 2. So the point 0 is negative 2. This is the first point, 0 and negative 2. And the tangent at y equals 0. At y equals 0, x equals what? Same. At y equals 0, back to the original equation, just remove y and write 0. If y 0, x will be negative 8. y 0, x is equal to negative 8. Now, we have it's by taking a cubic root will be negative 2. Will be negative 2 and 0. Now, we'll find m1, the gradient at 0, and the gradient at negative 1. Substitute by the gradient at 0, x0, and y equals minus 2 will be 4 divided by negative 2, all squared to 4 will be 12. Simplify will be third. The gradient is third. By the same way, substitute by negative 2 and 0. By negative 2 and 0, find the gradient. X is negative 2, negative 3, negative 2 all squared is 4. Divided by minus 0, 0, 2x, 2 times negative 2 is negative. Remove y and write 0, 2 will be 4. Will be negative 4. Simplify, your answer will be 3. Now, I will use M1 to be big, M1, and write this one to be M2. The tan alpha, angle in between, apply this form. M1 minus M2 divided by 1 plus M1, M2. So M1 is 3 minus third, all divided by 1 plus 3 times third. Simplify your answer to get tan alpha. After simplifying, you will get it 4 over 3. He asked to get the angle or tan angle. He asked to get tan angle, so keep it tan alpha is equal to 4 over 3. Thank you.